Hey everyone, welcome back to the LeetCode 75 challenge series. Today we'll tackle the problem max number of k sum pairs. So this is a medium level problem and I'll walk you through the problem statement, brute force solution and two pointer solution and finally our optimal solution. So stick around till the end to understand all these approaches with clear examples. So here's the problem statement. We are given an array of integers num and integer k. So our task is to find the maximum number of operations we can perform on it. So in one operation, we pick two numbers from the array whose sum equals k and remove them from the array. So let's understand this with an example. So given example here 1, 2, 3, 4 and k value is 5. So first we need to remove 1 and 4 since they add up to value 5. So after removing this, our remaining array would becomes 2 and 3, and then we again remove 2 and 3 leaving the array empty. So finally here that's a 2 operations in total. Coming to the second example, from the given array 3, 1, 3, 4, 3 and k value 6, starting with nums, we'll remove the first two 3's since they add up to 6, which is our k value, making our nums array values 1, 4, 3. So from this remaining array, we can observe that there are no more pairs that sum up to 6. So hence we need to return 1, which is our total number of operations. So let's start with our brute force approach where we check each and every pair of elements to see if their sum equals k or not. And for each pair that satisfies the condition, we'll increment our counter and we'll remove both elements from consideration. So let's quickly try run our brute force approach using this example. So we'll use two for loops to check each and every pair in this given array and we'll check whether they both add up to our value k or not. So we'll start from index 0 where we point I and we'll start j from I plus 1 and we'll check whether these two index values add up to value k or not. So if they add up, we'll mark these two indices with -1 and increment our count to our value, which would be initially 0. So let's quickly try run this. So these two doesn't add up to value 5, so we'll move our j pointer. So again they don't add up, we'll again move our j pointer. So since they both add up, we'll increment our counter value 1 and we'll mark these two indices with -1. So our array becomes -1, 2, 3, -1. So again we'll move our I pointer and start it from index 1 and j starts from I plus 1. So again they both add up to value k, which is 5. So we'll increment our counter value from 1 to 2 and we'll mark these two index values with -1. So since all the elements are marked as -1, we'll stop our iteration and we'll return our counter variable. So in this case, our value would be 2. So for this approach, the time complexity would be O of n square as we are using two for loops to check each and every pair, and space complexity would be O of 1. So let's move on to our code and let's submit. So here's the code for our brute force approach. So here I've taken the size of an array and I've also taken the count variable. I've used two for loops to check each and every pair and if they both add up to our value k or not. And since we are marking the elements with -1, we also need to handle those cases where we encounter an element whose value is -1. So if we encounter a value which is already being marked, so we'll skip that element by using this particular condition where if we find nums of I is nums -1, then we'll skip that element. And same goes with nums of j. If we find a value which is already being marked, we'll skip that element. Here I've used a condition where we'll check whether both values adds up to value k or not. So if they both add up to k, we'll increment our count variable and we'll mark both values as -1 and we'll break from that iteration. And finally, after finishing our two for loops and checking each and every pair from our nums array, we'll return our count variable. So let's submit this. As you can see, this approach gives us time limit exceeded because of our time complexity, which is O of n square, which is inefficient for larger arrays. So let's move on to our second approach, which is two pointers approach. It's a common technique for solving problems involving arrays which are sorted. So the steps for our second approach would be to first sort the array if not already. So we'll use two pointers, one starting from the beginning, which is the leftmost index, and the other at the end of the array, which is n-1. And here we'll check if the sum of both nums of I and nums of j equals k or not. And we'll move both pointers inward and increment our count variable. And if the sum is less than k, we'll move the left pointer rightwards to increase the sum, and if the sum is greater than k, we'll move the right pointer leftward to decrease the sum. So let's quickly try run this approach using this example. So pointer I starts from index 0 and pointer j starts from the end of the array, which is n minus 1. So we'll check whether these two nums add up to value k or not. So 1 plus 4 adds up to 5. So since it's a match, we'll increment our count and we'll move both pointers one step ahead and one step backward. So I moves to next index and j moves one index backward. So again we'll check the nums of I and nums of j adds up to k or not. So since 2 plus 3 is 5, again it's a match, so we'll increment our counter and we'll move our pointers both inward and backward. So j moves here and I moves here. So since they both cross each other, we'll stop our iteration and we'll return our count variable. So again let's take another example. 2, 3, 5, 6 and k value is 8. So here since the array is already sorted, we'll skip that part. So we'll take two pointers I and j and we'll check whether these two values adds up to k value or not. So 2 plus 6 is 8. So since the addition of these two indices values gives us k value, we'll increment our count variable to 1 and we'll move these two pointers one step ahead and backward. So again these two values adds up to k. So we'll increment our count variable from 1 to 2 and we'll move these two pointers one step ahead and one step backward. So since these two pointers cross each other, we'll stop our iteration and we'll return our count variable. So in this case also our count variable becomes 2. So let's quickly code this approach and later on move on to our time complexity and space complexity. So here's the code for our second approach, which is two pointers approach. Here our first step would be to sort the given array if not already, and we'll use two pointers left and right, which starts from starting of the array and one starts from end of the array. We'll also take the help of a count variable which would track the number of operations, and finally we'll use a while loop where until or unless the left pointer is less than right pointer, we'll try to implement few steps. Here I've taken the sum value, which is the addition of both left pointer value and right pointer value, and we'll check whether these two pointer values adds up to our k value or not. And if it adds up to k value, we'll increment our count variable and we'll move both pointers one step ahead and one step backwards. And if not, if the sum value is less than k, we'll increase the sum. If it is greater than k, we'll decrease the sum by moving the pointers one step ahead and one step backward. And finally, after finishing our while loop, we'll return our count variable. So let's run this code. So let's submit. So as you can see, it's working, but here the time complexity is O of n log n as we are sorting the array, and space complexity is O of 1 as no extra space is used apart from the sorted array. So this is faster than brute force, but slightly less efficient than our optimal approach. So now let's move on to our optimal approach. So here we'll use the hash map to store the frequency of each and every number in this given array. So the key idea here is to check if the complement of the current number, that is k minus nums of I, is present in our hash map or not. So let's quickly try run with this given example. So we'll start iterating over this array and we'll store the complement of each and every current element in our hash map. While moving on and checking with each and every current element, we'll check whether the complement of this given number is already exist in our hash map or not. So if it exists, then we found a pair which adds up to value k. So if not, we'll store that particular number. So let's quickly try run with our example 1, 2, 3, 4 and k value is 5. So initially we start with our index 0. So here the value is 1. So we'll check whether the complement of this current number, which is 5 minus 1, 4, is already present in a hash map or not. So since our hash map is empty, we'll store the frequency of this current number in our hash map, which is 1. And we'll move on to the next index, index 1, and here the value is 2. So the complement of value 2 is 5 minus 2, which is 3. So we'll check whether 3 exists in our hash map or not. So since it does not exist, we'll store our number with its frequency in our hash map. So again we'll move on to our next index, which is 2 and has value 3. We'll find the complement of this given current number, which is 5 minus 3, which gives us 2, and we'll check whether these 2 exist in our hash map or not. So since it exists, we'll increment our count value from 0 to 1, and we'll decrement our frequency of that given number. Frequency of 2 becomes 0, and we'll move on to the next index, which is index 3, which has value 4. Again, calculate our complement, which is 5 minus 4, which is 1, and we'll check whether 1 exists in our hash map or not. So yes, it exists. So we'll increment our count variable from 1 to 2, and we'll decrement our frequency. So why we are decrementing this particular frequency? Because the array can have duplicate elements, and to handle that case, we'll decrement the frequency of that given number in our hash map. So after finishing the loop from this given nums array, we'll stop our iteration and we'll return our count variable. So in this case, the answer would be 2. And here the time complexity would be O of n, as we're iterating over the nums array once, and space complexity would be O of n, as we are using hash map. So let's move on to our code and let's finally submit. So here's the code for our optimal approach we have discussed. So here I've taken an ordered map which will store the frequency of each and every number from our nums array. Also taken the count variable which will store the number of operations we did. I've iterated over our nums array and I've calculated the complement. I've checked whether this particular complement is present in our map or not. So if we found a pair, we'll increment our count variable and we'll decrement the number of occurrence of that particular complement. And if not, we'll store the current number in our frequency map. And finally, after finishing our for loop, we'll return our count variable. So let's run this code. So let's submit. As you can see, this approach also gives a successful submission. So let's analyze the time complexity and space complexity of all the 3 approaches we have discussed. So the brute force approach takes time complexity of O of n square and space complexity of O of 1. The approach 2, which is 2 pointers approach, takes O of n log n time complexity and O of 1 space complexity. And our optimal approach, where we have used hash map, takes O of n time complexity and O of n space complexity. And that's it for today's video. We have explored 3 approaches to solve the maximum number of k-sum pair problems. So if you found this video helpful, hit the like button, subscribe to the channel, and let me know in the comments which approach you prefer. See you in the next video. Thank you.